Example 5 from 7.2 is the integral from pi over 6 to pi over 2 of sine of 5x times cosine of 4x. So we're always looking to do substitution first and not just start plugging in trig identities. So I'm going to think about this a little bit. U equals sine of 5x, for example, would give us a du of 5 times cosine of 5x dx, which kind of looks like cosine of 4x, but it's not close enough. There's not a good way to handle the fact that on the inside of the sine and the cosine function they have different numbers in there. So unfortunately we're going to have to take a look at our identities on our formula sheet and try to figure out what we can use. This is the integration strategy handout case 3.1c I, and you can see the identities listed there as well, that this is the one that applies. So we have sine of A times cosine of B, where A and B are different, and so this applies definitely in this case, where our A is 5x and our B is 4x, so this identity is a little bit more obvious than some of the other problems we do. So we're just going to go for this. This looks like a good thing, and see what results and if we can evaluate that integral. So I'm going to start writing this down. Instead of writing sine of 5x times cosine of 4x, I'm going to write the right-hand side of this identity with the 5x and the 4x plugged in for A and B respectively. So my 1/2, hopefully I don't forget that, sine of 5x minus 4x plus sine of 5x plus 4x. So was that helpful? It was definitely helpful because we got two integrals that we can make now, separated by the plus in the middle. We were allowed to do that. And then each of these separate integrals, which after we simplify we'll see are pretty easy, then we're home free. So I'm going to do that. I'm just going to show that simple inside. We got 5x minus 4x, which is x, so we just have simply sine of x. It's really easy. Plus, and then we have sine of 9x. Not as easy, but we can handle it. And now I'm going to, you don't necessarily have to show the integral broken up, but I'm going to show a little bit, a step or two beyond what I would expect on a quiz or test, but you should show detailed work. This gets a little more detailed than what I expect. Anyway, I'm taking the 1/2 out overall, so I better put some braces around here. And I'm going to take the integral of sine x separately from the integral of sine of 9x So next thing, the integral of sine x is simply negative cosine x. And I'm going to have to plug in, so just some notation that I need to do that. Yep. From here, I'm going to do my second integral. Not so bad, sine of 9x. And so this one is going to be kind of like negative cosine of 9x, but it's like we have to undo the chain rule, where we get that little byproduct of 1/9 for the antiderivative or the integral. If you prefer, you can do this part by substitution. That's sort of technically what we're doing, is just a simple one, so it saves us a lot of writing if we can do it without. Okay, looking good, except I did not take the derivative actually, that's a problem. So let's go back and fix that. Negative or minus 1/9 cosine of 9x. It's way better. And I still have not forgotten my 1/2, so that's good. Alrighty, I'm going to put all this together, and I'm going to try keeping my half out this time, see how that goes. And we have negative cosine x minus 1/9 cosine of 9x, and then we gotta plug stuff in. So, we're getting there, just all this detail work to do. Negative cosine of pi over 2 minus 1/9 cosine of 9 pi over 2. Next thing, we have minus negative cosine of pi over 6 minus 1/9 cosine of, let's see here, it's going to be 9 pi over 6. I'm going to reduce that thing to 3 pi over 2. Wow. These get kind of hairy sometimes. Keep going. Cosine of pi over 2. Alright, cosine of pi over 2. It's an easy one. 0. Cosine of 9 pi over 2. So let's think about this. This is going to be over 2 pi, so you can get the cycles of 2 pi out, and then we can get an equivalent angle that is between 0 and 2 pi, and it'll be more familiar. So I'm going to play this game, like divide this by 2 pi, and I'm still going to have some left. I can get a 4 pi out of that. 4 pi, which would be 8 pi over 2 plus pi over 2. And so overall what we got here is cosine of pi over 2, because the cycles of 4 pi is like going around twice. Counterclockwise. And then we end at pi over 2. So this is equivalent to pi over 2. We're taking the cosine of that, and that's 0. So it's a lot of work to get 0, but that's what it is. Alright, moving on. Next thing, cosine of pi over 6. So a quick review of finding sines and cosines when you have an angle in exact radians. Pi over 6 is like this. And there's an x and y, this is a unit circle. There's x and y coordinates associated with this angle on the unit circle. So the x is going to be, it's kind of dropped down here, it's further along than a half, and it's square root of 3 over 2. The other one cuts over right at a half, or at least that's what I try to draw. And then you need to remember that the x coordinate is the cosine of the angle, and the y coordinate is the sine of the angle. So now that I have that down, I can tell that cosine of pi over 6 is square root of 3 over 2. Alright, 3 pi over 2. Cosine of that is, oops, that's kind of a funky circle. Looking at the unit circle, pi over 2 is here. This is pi over 2 pi over 2, and then 3 pi over 2 is down here. So if I'm going to find the cosine of that, that is the y coordinate, or the x coordinate, which is 0. So kind of lucked out with a lot of zeros here. And I got minus and negative here, so I have square root of 3 over 2. And that's it. I'm just verifying my work here. Looks good. So square root of 3 over 4. And that's it for this example.